Okay, here's a video for 8.1 practice A. We are going to be talking about arithmetic and geometric series and sequences in this chapter. Each one of those has its own little formula. So if you just look at these formulas, we're just going to mainly be filling in the formula for a lot of these. So I would take a look at it. I've kind of pointed arrows to what everything means to help you out. So this is the term that we're looking for. Okay, and now terms, and let me kind of go back and explain a little bit of what terms are, because it says right the first 6 terms of the sequence. A sequence of numbers is just like this right here. Numbers separated by commas in a row that might have a pattern. In this case, it would be adding 3 to each one. So a sequence is just when you have numbers, in an order, a specific order. A series is when you have numbers that are added together. So this is the series. Okay, so that's a little bit of a difference, but the formula doesn't change. So for a sequence or series, we're going to use the term that we want to get. Let's say we're looking for the 6th term, then this would be a to the 6th, or a6. If we want the 2nd term, then this would be a2. So whatever term we want, we're going to put that number for n. N means number of term. A1 is the first term in the sequence, plus n minus 1 would be this same number here, n, the number of terms that we want, minus 1, and then times d. And in an arithmetic sequence, you have a d, which is called the common difference. It's what you're adding to each one to get an arithmetic sequence. So an arithmetic sequence would be like these 3 right here. These are all arithmetic sequences, because they're going to be adding or subtracting to get to the next term. Geometric sequences we're not going to look at right now. This would be a geometric sequence because you would be timesing by 3. We're going to look at that when we get to 8.3. So I'm not going to do the geometric sequence ones, and I crossed them out on your puzzle as well. So when you go to your puzzle, you don't have to do the ones that are crossed out here on the notes. All right, so let's take a look at number 1. Now here's the geometric sequence or series formula, but like I said, I'll be showing you this more when we get to 8.3. All right, let's look at number 1. Write the first 6 terms of this sequence. Okay, so they're telling us that the sequence is this formula right here. If we want the first 6 terms, then we're just going to plug in 1, 2, 3, 4, 5, and 6 into the n. So 1 minus 3, 2 minus 3, 3 minus 3, 4 minus 3, 5 minus 3, and 6 minus 3. We're going to put in the numbers 1 through 6, 1 through 6. So if these were all separated by commas, this would be a sequence. The common difference in this is when you're just adding 1 to each number. So that's why there's a 1 in front of this n right here. Well, you'll see how that works out as we get to the formula a little bit more. So that would be number 1. You're just taking 1 and subtracting 3, taking 2 and subtracting 3, taking 3 and subtracting 3, and so on until you get to 6, and those are the first 6 numbers of our sequence. Number 3, you've got a n to the 3rd power. So if we want to find the first 6 numbers, we got to put it 1 to the 3rd, and then we put in a 2 to the 3rd, then we put in a 3 to the 3rd, and a 4 to the 3rd, and a 5 to the 3rd, and a 6 to the 3rd. And I've done all those for you in the calculator. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. And then you got 125 for the 5 to the 3rd power. 6 to the 3rd power is 216. So the first 6 numbers of our pattern would be these 6 numbers right here. Okay, that would be number 3. I'm just doing most of the odds. So number 5 is over here. Okay, it is also a geometric sequence, and I'll show you why, but we're not going to worry about those as much. But to just plug in numbers 1 through 6, that's easy to do, so we're not going to count it as a geometric sequence. We just wanted to see what happens when we plug in numbers 1 through 6. So 2 to the n means 2 times 1, 2 times 2, 2 times 3, 2 times 4, 2 times 5, 2 times 6. Okay, so 2 times 1 is 2, and then 2 to the second power is 4. 2 times 2 is 4. 2 to the fourth power would be 2 times 2 times 2 times 2, which would be 16. To get from 4 to 16, I just multiplied by 4. And then we put a 3 in there. 2 times 3 would be to the sixth power. So 2 to the sixth power means 2 times 2 times 2 times 2 times 2, 6 times. You get 64. And that, you can start seeing a pattern where you're just taking the answer and multiplying it by 4 each time. 64 times 4 is 256. 256 times 4 is 1024. 1024 times 4 is 4096. So this isn't a geometric sequence because the numbers are being multiplied by 4, but this is a pattern that would work right here. This 2 and 2 to the n power. So 2 to the 2 to the n power is what we have there. But we were just plugging in numbers 1 through 6, and that's all we did for those. All right, now let's describe the pattern right the next term. This is where writing the rule. This is where we're going to need our formula up here. So we're going to be looking at this top formula. Okay, so I'll be showing it to you as I plug it in. I kind of like to list all of the pieces. So A1 in my formula is 1 because that's my first term. The common difference is 3. They're 3 apart from each other. And they want us to get the fifth term because they want us to write the next term, and the next term would be the fifth one. So we have term 2, term 3, term 4. Excuse me. We want to get the fifth term. So we just got to start plugging them in. So a to the fifth term, that's what we're looking for, would be a 1 because we are going to start with a to the n. We want a to the 5, and a to the 1 is our first term. Our first term in this sequence is a 1. Plus, we want the fifth term, so that's going to be the 5 minus 1, because it was n minus 1, but n was 5 right here, because we want the fifth term. So 5 minus 1, and then our common difference times by 3. So 5 minus 1 is 4, and when we do 4 times 3, we get the 12. So 1 plus 12, your fifth term is going to be 13. Now let's check and see. Is that 3 more than 10? Yeah, it is. That is 3 more than 10. So if I plugged it in. So the first thing was describe the pattern is adding 3. Writing the next term is 13. Excuse me. And then now we got to write a rule. So now we're going to use the n because the rule is going to have an n. So n is going to stay here and n is going to stay here. But we're going to put in the a to the 1. We want our first term and we want our common difference. So a to the n would be 1 plus, and then we're going to distribute that 3 to both terms because it's being multiplied. So 3 times n, you get 3n. 3 times 1, you get 3, and it's a minus. When you combine the like terms, 1 and a negative 3, when you combine them, you get a negative 2. So 3n minus 2. So that was your last thing. That was the rule. Let's go to number 9. So let's list A1 is 1.5 because that's our first term. They're all 1.5 apart from each other. Okay, and then that's our common difference, 1.5. And then we want to find the fifth term again. We have 1, 2, 3, 4 terms. We want the fifth one. So n is going to be a 5. So we want a to the 5. We want the fifth term in our sequence. So 1.5 is our A1 plus we want the fifth term. So 5 minus 1 again. That's going to be a 4. And then the common difference is 1.5. So that's times. So when you multiply 4 times 1.5, you get 6. And then when you add that to 1.5, you get 7.5. So if you look at if I was to add 1.5, I would get 7.5 for my next one. Number 11. Where did I do 11? That's over here. Okay, so you've got your A1 is 4.7. They're all negative 1.3 apart. Negative 1.3 is my D. And my N is 5 because I want the fifth term again. So I'm looking for the fifth term. I've got term 1, term 2, term 3, term 4. So N is going to be 5 terms. So I want the fifth term. So I want A to the fifth, A5, A sub 5 equals the first term at 4.7 plus 5 minus 1 because I'm looking for the fifth term again. So this is always going to be 5 minus 1 when we want the fifth term. So that's going to be a 4 times a negative 1.3 is negative 5.2. And when you subtract those, you get negative 0.5 as your fifth term. So my next number here would have been negative 0.5 because I would have kept subtracting 1.3. All right, so that is number 9 and 11. Now, what I did forget to do on those, which I should do for you, is write the rule. So let's write the rule for those two real quick. Let's put it back in with A to the N. So let's go back to number 9. Okay, we found out that our A5 was 7.5. So let's find out what AN is. The first term is 1.5 plus, and we want to keep N, so N minus 1, and then our common difference was 1.5. So what I need to do is distribute the 1.5 to both terms. So A to the N is going to equal 1.5 plus 1.5N minus 1.5, because 1.5 times negative 1 would be negative 1.5. So those are going to cancel out. The only thing you're going to have left is just the 1.5N. So A to the N equals 1.5N. That would be my rule for number 9. So number 9, the rule. Let's find the rule for number 11. Okay, so that's up here. Okay, so you can see 9 and 11. Okay, so let's plug in what we need. Okay, so we want A sub N. Okay, our first term is 4.7 plus N minus 1 is what stays there because we're looking for the rule. And then negative 1.3 is my common difference. So I'm going to multiply that by negative 1.3. I still need to distribute that. So A to the N equals 4.7 plus negative 1.3N plus 1.3. Because a negative times a negative is going to be a positive. So A to the N equals, and we got to combine our like terms. You're actually going to get 6 positive minus, because it's going to be a negative 1.3N. So that would be our answer there. So that's, if you plugged a 1 in there, you would get 4.7 because A1 is 4.7. So that's just the formula that gets you any term that you want. And that's called a rule. It's a formula that gets us any term that we want. Okay, so let's go to number, let's see, we're not going to do 13 or 15. So let's go to 17. Now 17, it says using summation. So let me show you this little chart here. I did a summation, a little picture, so you can see what each thing means. Now this capital E is the sigma letter, and it means sum of. So sum of, and this is how many terms we want, or basically what is the last term. We want the fifth term to be our last term. We're going to start with the first term. This is the first term, so we're going to start with the 1. We're going to start with the number 1 term. Sometimes you might start with second term, or start with the third term, or so on. And whatever's here is our formula. That's what we're going to plug them into. Okay, so let's see what we got here. Okay, so it says write it as a summation. So to do that, we need to find the rule first. So what I did is I plugged it into my rule. I said, okay, I want to find my formula. So a to the n, I want to find my a to the n. So my first term is 3. Put that as a1. Plus, and I always do n minus 1 when I'm looking for my formula. And these are 6 apart from each other. These are all 6 apart. So my common difference was 6. Now I distribute the 6 to both terms. And I made one little mistake there, so let me fix that. 6 times n is 6n, not 3n. So let's fix that right there. Okay, so 6 times n, 6n, 6 times negative 1 is negative 6. And this would also be, this would also be 6n then right here too. So 6n minus 3 is your formula. So what I did was, once I found the formula right here, I put the big letter E, and it was 5 terms long. 1, 2, 3, 4, 5. And we started with term number 1. And that's what we would get right there. Okay, so 19. Okay, now this one's a little different because you got the 3 dots. That just means it's an infinite formula, so you got to put the infinity symbol on the top. And so my first term is negative 1 plus n minus 1, because I want my formula. My formula always has n's in it. And then my common difference between them is adding 2. Just keep adding 2. So my common difference is 2. Distribute, you get 2n minus 2. Negative 1 and negative 2 together makes negative 3. So 2n minus 3 is your formula. Starting with term 1. And then it's an infinite formula. So if I put a 1 in there, you're going to get 2 minus 3, which is negative 1. That is our first term. So that was 19. All right, so how do we find the sum if they're giving us the summation? Well, what they're telling you here is they're telling you what number to start with. They're giving you the function, and then they're telling you how far to go. So this is the last term. Sorry, not the first term. What I was putting there. So this is the last term. The top number is your last term. So we want to start with a 1, put a 1 in there, and we want to go all the way up to number 5. So we start with a 1 and we go up to 5. Where did I do that one? I did it somewhere. Right here. Okay, so it's right in there. Okay, so you can see that the formula is 6 times the term. And we want term 1, term 2, term 3, term 4, and term 5 because we want 5 terms. So 6 times 1, 6 times 2, 6 times 3, 6 times 4, 6 times 5. Multiplying them out, adding them together gives you 90. So that's the sum of those numbers would be 90. 25, we want 7 to be our last term. At this time, we want our first term to be a 2. So we would start with a 2 in here, not a 1, starting with a 2. So 3 times 2 plus 2, 3 times 3 plus 2, 3 times 4 plus 2, and so on, until you get to 3 times 7 plus 2, because 7 right here is our last term. We want to put in term 7. So when you add all of these together, you get 93. You get 93, sorry. And then I think that's it. Yes, so that is it for 8.1. So you just work on the puzzle. Just work on the ones that do not have an X through it. Those are the arithmetic sequence. All right, good luck.